Hello Math 30-2 and welcome back. Today we're looking at our very last lesson with logarithms and exponents. Before we looked at exponential laws and how they are applied in real life, now we're going to look at log scales and how they're applied in real life, okay? So for instance, earthquakes. This relates to a log scale. Up here, they just have some information that's based on, it gives you in-depth information about Richter scale. You don't have to memorize most of it. The only part that's important is to know that the Richter scale goes by power of tenfold, you might say. So for instance, if it is 1 greater, it is 10 times more intense. If it is 2 points greater, it is 10 squared more intense. So that's like 100 times more intense. If it is So the difference between this and this is 10 times. The difference between this and this is actually 100 times intensity more. So you've probably heard this before, like seen on movies where they have, oh, this earthquake was 2.3 on the Richter scale. Okay, and then this one was 5.5 on the Richter scale. Well, that one was over 100 times greater, the force of it. All right? So here we go. We're just going to quickly go over these here. And this first example, it says, an earthquake of the magnitude of 8 is how many times and more intense as the earthquake as the magnitude of 7? So intense means stronger. In this case, it is 10 times more intense. Because we're going with the exponents here. It's like 10 to the power of what? So it's 10 times more intense. An earthquake of the magnitude of 7 is how many times more intense of an earthquake of the magnitude of 3? Well, what's the difference here? 7 minus 3 is equal to 4. So that's 10 to the power of 4. Which gives me 10 to the power of 4. So this one is 4 zeros. It is that many times more intense. Okay. Now what about this? An earthquake of a magnitude of 4 is how much more intense than a magnitude of 6? Well, for this one here, I'm going to have to go 4 subtract 6. Well, that is going to give me negative 2, which gives me 10 to the negative 2. Well, 10 to the negative 2 is the same as 1 over 100. So it's 100th as intense. So this one here is 100th as intense. Well, think, 6 is 100 times more intense, so then 4 is going to be 100th as intense. Next one here says, an earthquake of a magnitude of 4.8 is how many times more intense than magnitude of 6.8? Well, same idea. We have 4.8 subtract 6.8. We want this one compared to the other one, which is going to give me negative 2. 10 to the negative 2. Which is the exact same as this, because they're 2 apart, which is 1 over 100 times as intense. The last one here, it says, the earthquake in Chile was so many times as intense as the 1970 earthquake in Italy. So let's take a look here. Go to our table. Chile is 9.5. We want the Italy is 6.5. So we go 9.5 subtract 6.5, this gives me 3. So that's 10 to the power of 3. Oops, sorry. Which is 10 to the power of 3. So that's 1,000. Okay? And how much was the earthquake in Colombia in 1983? So let's look at 1983 Colombia, 5.5. Well, 5.5 to 9.5 is a difference of 4. So that is 10 to the 4. So that's 1,000 or 10,000 times stronger. So it's 1,000 times stronger than the Italy, 10,000 times more intense in Colombia. And then the last one says in 1996 the earthquake in Turkey was how much more intense as the 1933 Japan? So let's look. 96. There's Turkey. And now we want Japan. And we want the 33, 6.9 to 8.9. That's a difference of negative 2. So that's the same thing as 10 to the negative 2, which is 1 over 100. Because I go Italy, subtract, oops, what was it? Turkey, subtract Japan, which gives me -2. All right? So that's how we do those. And that's how you get your intensity of earthquakes, to know how intense they are. Now, eventually, they came up with this formula here. Okay? The intensity. So it's saying the intensity of the first earthquake compared to the second is equal to 10 to the m-1, the magnitude of the first minus the magnitude of the second. Or in other words, the magnitude of the first minus the magnitude of the second is equal to the logarithm of this divided by that. Because if we do this, all we do is we log both sides. If I was to log this, this is in base 10. So that's like saying all this divided by log 10, right? Because we'd have to divide this by log 10 if we were rearranged. Okay? So that would give us this. All right? If you need some help understanding that, I can help you. I can explain this to you tomorrow more if you have a question on that. Okay. So now it says, how many more times intense? So this is our main formula. And almost every time they'll be giving you this formula on the differential equation. So how many times more intense was the 1960 earthquake in Chile, magnitude of 9.5, and the 2000 of a magnitude 7.8? So I want to know that intensity. So I have my intensity of 1 over my intensity of 2. So this will give me my intensity ratio. Okay? How many more times? So 1 divided by 2 will give me how many more times intense 1 was than 2. Is equal to 10 to the power of, well, we want, number 1 is Chile. So we have 9.5. Subtract 7.8. Okay? I put that in my calculator. Here, calculator, and I am going to end up getting 10 to the 1.7, which is equal to 50.11. Okay? That's how we do that one. So then it is 50 times more intense. Okay? Because it's 1.7, that's hard to do. That's not going to be 100, it's not 10, it's in between, and it's 50 times more intense. All right. Let's take a look at our next question. It says, a major earthquake of a magnitude of 7.5 is this much more times as intense as a minor earthquake. Huh. So, is the magnitude of the minor earthquake greater or smaller than 7.5? Well, it is more intense. It's not a fraction or a decimal, so it is greater. Oops, sorry. It is smaller. Sorry, is it greater or smaller than 7.5? So, a major earthquake, a magnitude of 7.5, is of a minor earthquake. So the minor earthquake is smaller. Okay? Because it's going to have to be 7.5 subtract something, 10 to the power of 7.5. If we look at it, it's 10 to the power of 7.5 subtract x must equal to 375. So we know that it must be, this has to be bigger, because if it's a negative, it's going to be 1 over something. So use the formula to determine the magnitude of the minor earthquake. So we know our ratio is 375. So this here's my ratio is equal to 375. And I have 10 to the power of 7.5 minus x. Well, now we have this really confusing equation. So what must I do? I'm going to log both sides to solve this one. I'm going to log 375 is equal to log 7.5 minus x, and this is all to the 10. Okay? So I'm going to continue this here. Well, what do? I'm going to continue this here, and I multiply this in, so I'm going to get 7.5 log 10, subtract x, log 10 is equal to log 375. Okay? So I'm going to subtract 7.5 log 10 from both sides. So that's log 375 7.5, subtract log, and I have 10 to the 7.5. Okay, and that is all equal to, I'm running out of room here, x log 10. Okay? So when I do this, we could combine this. This is the same thing as log 375 all over 10 to the 7.5. Just going to do a big number. All divided by log 10 is equal to x. Negative x. Well, log 10 is just log 10. That's base 10. 10 to the power of what? So that's 1. So all I have to do is put that in and multiply that by a negative. So what am I going to end up getting? Let's take a look at this. I'm going to get log 37.5 or 375 divided by, and I'm going to put my brackets, 10 to the power of 7.5, and put my bracket, enter. I get negative 4, so then negative x is equal to negative 4, so I multiply that by negative 1, and I get 4.9. So x is equal to 4.9. So that's the magnitude of x. It is 4.9. Okay? Hopefully that helps. All right. So the next one here we're going to look at is going to be sound. Okay? Another one, you could have done this in another way too, which might have been easier. Just kind of. So now here we're looking at sound. Now sound is the decibel system. Okay? So a leaf rustling is 10 decibels or 1 decibel. So it's the same idea as the other one. The scale of sound is a logarithmic difference of 1 bell or 10 decibels. Corresponds to a factor of 10 difference in sound intensity. So it's the same idea as the one before. So if I said 120 decibels is how many times as intense of a dial tone of 80? Okay. Well, 120 decibels is 12 bells. Okay? 80 decibels is 8 bells. Okay? So we're just looking at this. There's decibels as 1/10 of a bell. Okay? So we just put it in bells. Now, if I look at that, I know these, 1 bell is 10 times as intense threshold hearing, so it increases 10 times. So we have 12 minus 8 is equal to 4. 12 minus 8 is equal to 4, so that is 10 to the power of 4, which is equal to 10,000. So let's take a look at the next one. A jet engine of 20 millimeters is 145 decibels, and this one is 12.5 decibels. So how many bells is each of them? Always convert first to bells. So I'm going to get 14.5 bells and 12.5 bells. Okay? So I convert this. This is the difference of this is 14.5 minus 12.5 is equal to 2 bells. Well, that's 10 to the power of 2. 10 to the power of 2 is equal to 100. That's it. Last one here is a whisper of 30 decibels is how many times of 60? Well, that is 3 to 6. So 3 subtract 6 is equal to negative 3. So that's 10 to the negative 3 is the same as 1 over 1,000. Okay? That's how we do that. So now we're going to interpret sound. So sound is equal to this. Your number of bells, or is equal to, or decibels, is equal to the log of, this is for bells. If you're in terms of bells, it's equal to this. Okay? If we're looking at decibels, here's your formula. It's based on that. So these are your two formulas for both. If it's in bells, it'll say this. If it's in decibels, it'll say that. You don't really have to memorize this formula. They'll normally give it to you. So, how many more times as intense is the sound of a piano playing 67 decibels than a whisper? So we're looking at decibels. We're going to have to use this equation here. Okay? So wants to know how many more times intense. We'll find the intensity. Intensity is I over I. So that's your intensity, and we want to know how many more times. So that's this divided by this will tell you how many more times intense. If I said how many times more money does this person have than this, well, you go that person's money divided by the others. So we have to look at this. We know it is, let's put everything in our equation here. If I subtract these, it's not going to be perfect. We're going to end up getting 45. So we have to go 10 to the power of 67 minus 22 all over 10 is equal to my intensity. Okay, my intensity ratio. Well, we plug that in our calculator. I'm going to end up getting, this is equal to 10 to the power of 4.5. Yep. Which is the same thing as, plug it into your calculator, you're going to end up getting 10 to the power, or 31,623. So it's 31,623 times more intense. Okay, now let's take a look at number 6. So given that the decibels for this log right here, okay, the threshold of pain is 125 decibels. Okay, has a sound intensity of that for I naught. Okay, so we want to show that the decibel of pain has a sound threshold of that there. So how do we do this? So I have 125. That's my threshold. Okay, of pain is equal to 10. We're going to have to use the log one. Okay, so we're talking about, we're going to have to use the log one, and we're going to use this one because we're looking at decibels. Okay, and it says given at this, show that the decibel level, we want to find the decibel level of sound. So we're trying to find the decibel level is 12.5. So we're finding the level. We're not working on intensity, we're finding the level. So we're trying to find decibel. We're finding the level, so we're going to have to work a bit different. So we want to show that it is actually that. Okay, so we have 125 is equal to 10 log. Okay, so you're this over your initial intensity. Okay, so we just plug this into the formula. Now, we're just going to solve given the plugging into the formula. And we want to solve for this guy there, I naught. That's essentially what we want to do. Or sorry, we want to solve for intensity. So, how do I do this now? I'm going to divide both sides by 10. We're solving for this guy. Okay? So we divide both by 10. So I get 5 by 10, 5 by 10, we get 12.5 is equal to log. Alright? Now the next part we're going to have to do is, well, what is this saying? This is saying something. 10, we're going to have to rearrange this for these equations. We want I all by itself, this intensity all by itself. So the intensity of this all by itself. So we want this. What is the intensity of that? That is this guy. So we're isolating for him. So I'm going to have to change this to maybe exponential. This is in base 10. So it's saying 10 to the power of 12.5 is equal to I over I naught. So now what I'm going to do is multiply both sides by I naught. The intensity of my original and that gives us the same as this here. And that's how we do that, okay? So that's it for now. The second half we will do it later. Hopefully you guys understand this as we go through it tomorrow as a group.